Hi folks, this is Calc 2 Quiz 5. We're given an integral here, a rational function. And so anytime we have a rational function, the first thing we check, will long division do us any good? The degree of the denominator here is 4, the degree of the numerator is 3, so long division isn't going to accomplish anything. So the next thing we do then is check for partial fraction decomposition. And so to check that out, what I need to do is factor the denominator. I can pull an x squared out of both terms. I get x squared plus 9. This is an irreducible quadratic. So my partial fraction decomposition is going to look like a over x plus b over x squared plus cx plus d over x squared plus 9. Remember, we treat the x squared not as an irreducible quadratic. X squared is actually a repeated factor, x times x, and as such we treat it as a repeated linear factor. The x squared plus 9 we know is an irreducible quadratic because the roots of this polynomial are imaginary, and so that's why it gets that kind of treatment. Alright, so that's the first step, is to write the form of the partial fraction decomposition. Alright, this is our auxiliary equation now, so we're going to multiply both sides by the x squared and the x squared plus 9, and we're going to get 2x cubed plus 2x squared plus 27 equals a times, now when I take this fraction times this denominator, it's x times x squared plus 9. And we're going to get plus, if I take this denominator times this term, the x squares cancel, I have b times the quantity, x squared plus 9. And I can take this times the last, I'm going to get cx plus d times x squared. And so if I multiply this out, I'm going to get 2x cubed plus 2x squared plus 27 equals ax cubed plus 9ax plus bx squared plus 9b plus cx cubed plus dx squared. Okay, so I've rewritten this equation. Now we can match up the like power of x. So we have x cubed, x squared, x, and then the constant. And we have the left-hand side and the right-hand side. On the left-hand side, the coefficient of x squared, or x cubed rather, is 2. On the right-hand side, we have ax cubed plus cx cubed. The left-hand side, the coefficient of x squared is 2. On the right-hand side, it's bx squared plus dx squared, so that's b plus d. The left-hand side, we have no x's. On the right-hand side, we have 9ax's. Left-hand side, the constant's 27, and the right-hand side, the constant's 9b. So this sets up a systems of equations. We have a plus c is 2. We have b plus d is 2. 9a is 0. 9b is 27. This gives us that b is 3. This gives us that a is 0. When I substitute b is 3, 3 plus d is 2. D is negative 1. A plus c is 2, but a is 0. That means that c is 2. Alright, so what does that mean? That means that the 2x cubed plus 2x squared plus 27 over x to the 4th plus 9x squared is equal to a over x, but the a is 0, plus b over x squared, so that's 3 over x squared, plus cx plus d, so 2x minus 1 over x squared plus 9. So that means when I integrate this, I can integrate this instead. So I'm going to integrate 3 over x squared plus 2x minus 1 over x squared plus 9 dx. I can split this to the integral of 3 over x squared dx plus the integral of 2x over x squared plus 9 dx minus 1 over the integral x squared plus 9 dx. This is a Calc 1 integral. This is negative 3 over x. This is a beginning Calc 2 integral. That's a natural log. We don't need the absolute values because the x squared plus 9 is always positive. And this is a beginning Calc 3 or Calc 2 integral minus a third arctangent of x over 3 plus the ubiquitous constant. And that'll do it for quiz 5.